Welcome to The Explainer. Look, right now, the hype around AI agents is absolutely everywhere. It seems like literally every new software update claims to be agentic. But if we strip away all that marketing buzz, what exactly is an AI agent? How is it actually different from the chatbot you were using yesterday? And maybe more importantly, how are these systems actually built under the hood? Today, we're going to do a complete, BS-free teardown of the anatomy of AI autonomy.
Okay, let's dive right into this. Here is our masterclass roadmap for today. 1. Chatbots versus AI agents. 2. How AI agents think. 3. The 7-layer tech stack. 4. Giving AI memory and tools. And finally, 5. The cost of autonomy.
Starting with Section 1, Chatbots versus AI agents, a shift in architecture. This isn't just a branding exercise, guys. It's a fundamental shift in how these systems operate. To ground ourselves, let's quickly trace how we actually got here. We've really seen 4 generations of AI chat systems. Generation 1 takes us way back to 1966 with scripted rules. Think of those super frustrating support bots that just try to match keywords. Generation 2 hit in 2017 with the transformer architecture, which gave us incredibly fluid natural language generation. But it wasn't until Generation 3, right around late 2022, that large language models were actually paired with external tools, and that evolution led us straight into Generation 4, today's modern agentic systems. That Generation 3 leap, that's where the magic really started happening. Architecturally speaking, a chatbot is essentially a brain in a jar. It takes your prompt, makes a single inference call, and spits out session-scoped read-only text. It can easily tell you how to process a refund. But an AI agent, that is a brain with hands. It's fiercely goal-oriented. It enters into a multi-step autonomous feedback loop where it can actually use external tools to issue that refund for you. Which brings us to the million-dollar question, right? An LLM at its core is just a text prediction engine. So how on earth does a text predictor actually do something in the real world? To answer that, we move into Section 2, How AI Agents Think, the Cognitive Framework. The secret sauce here is a concept called REACT, standing for Reasoning and Acting. This was a really pivotal concept from a 2022 Princeton and Google research paper. The researchers basically figured out that if you prompt a model to interleave verbal reasoning traces, which are basically its inner thoughts, with task-specific actions, the model performs exponentially better. It mimics human problem-solving beautifully. Think about it like when you're cooking. You think to yourself, okay, the water is boiling, now I need to act by dropping the pasta in. REACT forces the AI to do exactly that. And this creates what we call the REACT loop, broken down into 3 simple steps. First, the model reasons and plans based on its goal. Second, it acts by selecting a tool and executing it. Third, it observes the result and replans. For example, in that original research paper, they tested an agent navigating a simulated kitchen just trying to find a pepper shaker. The agent thinks, I need to find a pepper shaker. It's probably in a cabinet or on a countertop. It acts by moving to cabinet 1. It observes there's only a vase in there. It replans and moves to the countertop. This loop just continues autonomously until the goal is totally met. But deploying that cognitive loop in the real world requires some serious physical infrastructure. That brings us to Section 3, the 7-layer tech stack, production infrastructure. When we map out production, it is so easy to get completely fixated on layer 1, the foundation model. You know, your GPT 5.5s or your Claude 4.6s. But listen, the foundation model is literally just the brain. It's the other 6 layers stocked beneath it that actually determine if your agent works or just crashes and burns. Right beneath the foundation model is layer 2, the orchestration framework. Think of this as the nervous system of your agent. This is where that REACT loop is actually coded, controlled, and executed. If you're building a multi-step task runner, you're probably using frameworks like LangChain or LangGraph. If you're building a whole team of specialized agents that need to talk to each other, you might spin up CrewAI. But even with a stellar brain and a perfectly wired nervous system, things still go sideways. Which leads me to this honestly staggering question. Why do 95% of enterprise AI pilots totally fail to deliver any measurable ROI? We find the answer in Section 4, Giving AI Memory and Tools, Hands and Recall. According to a really interesting finding from Atlan, it turns out these AI pilots aren't failing because the models are dumb. No, they are failing because of context readiness. Simply put, out of the box, LLMs have absolute amnesia. Every single time you talk to them, it's like a brand new conversation. Without memory, an agent absolutely cannot do complex long-term work for you. To fix this amnesia, a production agent requires 4 very distinct types of memory. Working memory is the active context window, what's happening right now. Episodic memory is the log of prior interactions so the agent actually remembers what you did together last Tuesday. Semantic memory is external factual knowledge about your specific business. And procedural memory encodes the strict rules and workflows the agent has to follow. To pull this off in real time, especially for episodic and semantic memory, agents rely heavily on high-speed data platforms like Redis for that lightning-fast, sub-millisecond context retrieval.
Now, that semantic memory is primarily handled by Retrieval-Augmented Generation, or RAG. Foundation models obviously don't know your proprietary company data, so you convert your documents into numerical embeddings and basically store them in a vector database like Pinecone or Chroma. When the agent needs an answer, it searches this database to retrieve only the most relevant chunks of data. This keeps the agent grounded. It stops it from hallucinating wildly outside of its training data.
All right, once the agent has a solid memory, it needs its hands. Tools. Tools are quite simply functions that the model can choose to call. This could be running a web search, executing Python code, reading files, or making API calls using standards like the Model Context Protocol. But here is the absolute critical point for developers. Tools schemas. The model itself doesn't run the code, it just decides what arguments to pass based on your description. If your tool schema is vague, the agent is going to pass the wrong data, and the whole action goes bust.
So wiring all this infrastructure together is incredibly powerful, no doubt about it. But it comes with some very distinct business realities. Let's look at Section 5, the cost of autonomy, business realities.
Because an agent operates in that constant multi-step React loop, it is inherently slower and definitely more expensive than a basic chatbot. Just to put it in perspective, in one benchmark, a standard chatbot sustained 6.4 queries per second. A React agent? Barely 1.2 to 2.6 queries per second. Plus, think about the failure modes. If a chatbot fails, you get some weird hallucinated text. If an agent fails, it might accidentally execute an irreversible action, like dropping a database. Because of that, agents demand significantly higher governance, very often requiring a human in the loop for anything high stakes. But it's not all doom and gloom on the cost front. Regarding those elevated inference costs, there are clever solutions. By using semantic caching services like Redis LangChain, you can actually cache previous LLM responses. If a user asks a predictable query that's similar to one asked before, the system retrieves the cached response instantly without invoking the LLM again. That little trick can reduce inference costs by up to 73%, a real game changer. Which brings us right to our final stack layers, observability and deployment. Unlike traditional software that crashes and gives you a loud error code, LLMs fail silently. An agent might hallucinate a completely bogus reasoning path, execute a faulty tool, and still confidently return a 200 HTTP success status. Crazy, right? You absolutely need deep observability tracing to track every single LLM call and tool invocation so you can catch these logic loops before they ever impact your users. Which leaves us with one final, slightly provocative question to chew on. As you scope out your next AI project, ask yourself, does your specific use case truly require full multi-step autonomy? Or do you just need a really fantastic conversational text generator? Both are incredibly valuable, but as we've seen today, they demand vastly different infrastructure. If you do decide you need an agent, I invite you to explore the 7 layers of infrastructure we covered today to make sure you build a system that doesn't just think, but successfully acts. Thanks for joining me on this explainer, and keep building.